for the attendance?
Yes, sir.
Okay, good. So this call now is being recorded. Let's see. Let me just check the attendance just to make sure that everybody are were able to log in for the attendance. So if only you're going to log in now for the attendance, only you can see is absent. We attendance. Okay, so that means to say Argawanan is absent. Who else? Godinez is also absent, but I saw Godinez and the streaming. And then Nuevo is not also present.
Sir, present, sir.
Who's that?
Nagawanan, sir.
No, but you did not log in the LMS for the attendance. The attendance was checked in the LMS. No, Nuevo just signed in after, I think this was just after I reminded the class. Rika is not also around together
Present,
with,
sir.
yeah, but in the LMS attendance, you are not around together with Ronica Tan. 42. May I know anyone from here who is not or doesn't have an access to the LMS up until now? You all have access to the LMS already? Okay, no one would like to talk. Okay, we will start our discussion. Uh, Very much quick recap. Sorry. Let's hear from Mendez. May I know what was our discussion last meeting? Mendez? Mendez. Hello? Bayot, what about Miss Bayot? What is our discussion last meeting? Where did we end?
We end types of measures, sir.
Sorry?
Yeah.
What was our discussion
We end
about?
Sorry, sir. About the level of measurement, sir.
We end with the level of measurement. May I know what is that?
Katong nominal level of measurement, sir. Ordinal level of measurement, interval, and ratio, sir.
Okay. Did I presented you through what do you call this one? PDF file where I shared to you through screen last time.
Sir, katong sa Gmail?
No, I'm asking you. When I presented the discussion last meeting, was it the one I took it from the LMS? I don't know. I took it from my PDF file. Was it from the PDF file? The one I shared? I shared to you the PDF file,
Yes,
correct?
sir. Yes, sir. Correct.
Have I uh, uh, have I emphasized the topic about independent variable? Hello,
Yes, sir. You did, sir.
I did emphasize the dependent and independent variable.
Yes, sir.
Okay. So this afternoon, I'm just going to emphasize again. I mean, our objective this afternoon's discussion is about um, variables with subscript. The same with other branch of mathematics and even mathematics itself. We deal unknown numbers or values as variables or any symbols or letter for that matter that will represent that unknown number. In such case, it's understood also that it's possible that we will present something, okay? We will present something, but it is come from the same kind, but of different values. For example, if we're talking about, um, let us say, we're talking about the different degrees or temperature in Tagaytay for the entire month of July, for example. So the variable there we're going to use is we're going to associate any letter or symbol that will be associated or that will represent the temperature in Tagaytay. Okay? Now, say for example, the temperature in Tagaytay is represented, we'll write it as variable x. So let x be the variable representing the temperature in Tagaytay. After that, if that is the case now, what about if you're going to record the temperature in Tagaytay for the entire um month of July? So say July 1 until July, I think July 31. If that's the case, still our variable is x. But we cannot also say that for the second day of July, July 2, we will still use x, the same x. But we cannot also change x itself. It's because we are still referring to the same variable. Do you get what I mean? So in other words, I represented my temperature in Tagaytay as variable x. Okay, that is my variable, or that's the unknown value, which now I represented it with variable x. What happened is, I wanted to find out as to how many or what is the temperature now for the entire month of July. So assuming that there are 31 days in July, and then I already use x to represent the temperature for the month of July, or at least the day for July. So, example, July 1, I have X July 1's temperature. Now, how am I going to represent now the temperature for July 2? That's the point now we will use the word subscript. Okay, examples N or X sub 1. By the way, in general notation, we use x sub n. The n here is called subscript. Okay? Subscript, well, basically, it's because it's a script, it's below. Or at least it's below. You use sub and then script, it's like a letter below something. Because what you will find here on top is called superscript. You have superscript and then subscript. But our concern now is only subscript. Since we're going to represent now the temperature of the month of July in Tagaytay, example, July 1 is represented variable x. And then we have x sub 2. Okay, we have the second subscript now. That is for the month of July 2. And then comma until we have x sub n. X sub n here is actually a general notation that would indicate the last month of July. In this case, our context is the month of July. So x sub n here refers to the last data entry, which is, in our example, July 31. So in this scenario now, it is assumed or the temperature of the month of July is recorded as variable x. Now, since there are 31 days for the month of July, we then use a subscript 1, 2, up until n, considering that there are several days in the month of July. So, x sub 1, x sub 2, until x sub n. By the way, this last expression we have here is what we call now the general notation. Okay? It's the general notation. So, if you look at this situation now, a variable towards the last, or in our subscript, for example, is already n, it's just like generic. It doesn't specify really. But we can just later on define what is this one. If, example, this is the general notation, we have x sub 1 until x sub n. But if it is month of July, instead of x sub n, we will now use, instead of x sub n, it should be x sub 31. Okay? Exactly, referring to the last month of July, since our variable here, x, is referring to the temperature in Tagaytay for the entire month of July. Am I making myself clear? Please, you ask question if you have some clarification. Please, you try to answer me also. If you don't have clarification, let me know. If there is, let me know. So at least I know what to do next. Hello, everyone. Let me know if you have questions. And at the same time, let me know also if there is no question so that I know what to do next. Okay, so someone said here, no question. Now, referring to this particular notation, example, we have the notation x sub 1, and then the second entry is, of course, x sub 2, then 1, 2, 3. By the way, this symbol here, the three letters, is called ellipsis. I'm not really sure the spelling though, but it's called ellipsis, meaning to say there are omitted terms. But for convenience of writing, we try to represent those omitted value or elements in our certain expression by three letters. It's called ellipsis. So I have here, and then I have x sub n. This is how we write it, at least in this way. But there is more convenient way of writing this one or presenting this notation. Okay? And we call this notation now as summation notation. Are you with me? Okay. Okay, we have the so-called summation notation. Of course, that is with the use of this letter. I don't know how to do it or to write it. Okay, it's sigma notation. At least Greek letter, capital Greek letter sigma, which in statistics once used, it's called summation. It's called the summation notation. So it's a notation used to show the summation, the sum of all the entries. So if you have this kind of situation here, and for convenience of writing, we're going to use now the summation notation to rewrite this one in a more presentable manner. We would write this as, okay, the summation symbol, and then after the summation symbol, we of course use our variable x. Now in this case, I'm going to use small I as a subscript. You notice I didn't use any number at all, nor n. What is I here? I here is also a collective term or at least a symbol that would represent any value of x. That is not the last one necessarily, of course. So it may be one, two, three, anything. And then with that, I'm going to write here, this is the limits of my summation notation. I equals 1. It means to say, when I have this notation, I'm referring to the value of the variable x, which started from 1. Here, the subscript x sub I means to say from 1, where I here would actually start from 1. The first value of x, example, in this case, I'm referring to the first value here. And then I will end with small n on top. So this is what we call now the limit of my summation notation. We will refer now this one. We have the summation of all x's, where x is from 1 until n. At least, I'm going to write this one in words, the summation of all x, comma, then where x is from 1 to n. Because the value here, I equals 1, would pertain to you as to where is the limit of your value. Because if I'm going to write here 5, then if I have the series of numbers or values of x here, I should only start with 5. Because my summation notation indicates only that what is included is from 5 until n, whatever is your n. Are you with me? Please let me know if you have question or at least you understood, because how would I know if you are still on the other side of the screen? Anyway, even if you're showing your faces there on the screen and then you're not actually there, it's not my loss. Because at the end of the day, who will suffer when I'll give quiz? It's still you. Anyway, any question? It's just a matter of being responsible. Okay, so let us take some specific example. Now, again, a literal way of writing it, we have it in this form. X sub 1, x sub 2, until x sub n, where x sub n is a general notation identifying whatever is the last value in your sequence. This is called sequence. Okay, sequence referring to the sequencing of number from the first entry, from the first element until the last. So definitely, if it is x sub n, there is a last term. This is called, by the way, finite sequence. Finite meaning to say there's an n. Because if it's infinite, we will remove the x sub n here. We will only end with the ellipsis. It implies that there are omitted terms wherein it doesn't really show any boundary. Meaning to say it doesn't show where to stop. But if you have ellipsis, then after that there is one more term, a general notation, which is normally using n as its subscript. Then that sequence here is called finite. Called finite, meaning to say the last term in that sequence is actually specified. Although we don't know what is it exactly, but definitely there's an end to your sequence. I hope you truly understand that. So we have the sequences in this form, but the sequence can be written in symbolic form, which is this way. Now let's take an example. Mhm. Let us say, okay, if I have here the notation, the summation of all x sub I, where x is equal to 1 until 31. Okay? If this is my notation, my summation notation, by the way, I will read this one as the summation of all x where x is equal to 1 until 31. It means to say I'm referring to the value of the variable x starting from the first value of x until the last value of x, which is 31. This one is, by the way, is equivalent to x sub 1. By the way, summation here implies addition. That's why it's called summation. So x sub 1 plus x sub 2 plus x sub 3 plus, I'm going to use ellipsis summing because there will be omitted terms. That's for convenience writing only because like I only have limited spaces here. Then plus x sub 31. In other words, this indicates that I will add all the values of x's starting from the first x until the 31st x value. So if I have here x, example, x sub 1 equals 5, x sub 2 equals 3, x sub 4 equals 7, and then dot, and then you have x sub 31 equals 10, for example. So the meaning of this one, of course, I wasn't able to write other terms aside from 3 and 31 because that's the point. I just don't have enough space. So the indication of this one, if this is my notation, the summation of all of these, the value. So if my variable x sub 1 is already given face, or at least given an exact meaning or value, which is 5, I would now have 5 plus the value 3, that is the value of x sub 2, plus, uh, sorry, x sub 2, and then I miss x sub 3. X sub 3, let's say it's 6, plus 6, plus 7, plus dot, plus 10. Meaning to say, I'm just simply going to add the values here. The values of x sub 1, the values of x sub 2, the values of x sub 3, the value of x sub 4, until the value of x sub 31. And then I'll just add everything. Okay? I hope that's clear. Question? Okay, very good. Now, concerning this idea, since we're now using summation notation, we have also to bear in mind that there are also certain rules that govern summation notation. What's only allowed and not allowed also, at least you will be guided what are the only things that is, or the only thing that is acceptable whenever you have a summation notation. We will start with rule number 1. Okay, by the way, just a very quick recap. This symbol is summation notation, meaning to say the sum of all. And then x sub I here is exactly our variable. Our variable here is x. I here, the subscript I identifies that there is more values of x in different forms. That's why we would now identify them as I as any value. Then we have here below, this is the limit, meaning to say we're talking about the values of x starting from the value of x, which is I, the first one, until 31. That's the last value of x. So meaning to say there are 31 x's, where we will start adding from the value of x sub 1 until the value of x sub 31. Now, first rule. Rule number one is actually we have this certain notation. We have sum and then x sub 1, or rather x sub I plus y sub I. So you notice in this case, there are already two variables, meaning to say you have variable x and at the same time you have variable y. Now in this case, it doesn't, because this is just a ruling, it doesn't necessarily identify as to which or what is until what value of x and y are we referring to, because we don't have the limit in our summation symbol. But the point here is that whenever you have situations like this one, according to the rule, it only identifies applying the distributive property. We would distribute the summation notation here inside. This is just equivalent to the summation of x sub I plus the summation of y sub I. Meaning to say the sum of all x plus the sum of all y. Very quick. If I have the summation of x sub I from I equals 1 to 5, for example. So meaning to say, I'll have to add all the 5 x's, the values of 5 x's, and then if I also have the summation of x or y sub I from I equals 1 to 3. So I also have to add all the values of y, and then I'll combine them. This is my notation. So let's say, for example, here, x sub 1 equals 5. X sub 2 equals 3. X sub 3 equals 7. X sub 4 equals 8. X sub 5, let's say 2. So example, these are the values of x's. Now, technically speaking, if this is the reason, I'll have to add all my x's. And let's say also y sub I equals 7, y sub 2 equals 10, y sub 3 equals 4. If these are now the values of the identified variable, if this is my general notation, or at least this is the question, the summation of the quantity x sub I plus y sub I, according to the interpretation, whenever we have it in this form, we have the summation of all the x's and then the summation of all the y's. And then we have to add them afterwards because we still have a summation notation outside. So first, we'll add all the, so this x sub 1 plus x sub 2 plus x sub 5. And then here, y sub 1 plus y sub 2 plus y sub 3. The value of all x here, x sub 1 is 5 plus 3 plus 7 plus 8 plus 2. 1, 2, 3, 4, 5. Then add all together, that is 10, 23, 25.
25.
Okay? And then for y, we also do the same thing, that is 7 plus 10 plus 4. Add all together, that is 21. So the meaning of this one here, accordingly, the sum of all x, which is 25, and the sum of all y, which is 21, combine them together, you have 25 plus 21, which will give us now 46. So that is the meaning of the first rule. Whenever we have the summation of the quantity x plus I or x sub I plus y sub I, it indicates or it implies that you have to find the sum of each variable. We will find the summation of each variable, and then at the same time we will add them as the result, and that will be the final answer. Did I make myself clear? Question. Take note that is rule number one. Because later you might encounter some terms, or at least you will encounter some questions about like this. At least you know what to do.
Excuse me, sir.
Mhm.
Okay ra, sir, during kanang solution, sir, baka i-shortcut lang ang kuan ang solution or needed
Which one?
gid siya nga i-kuan
Which,
i-infer nga sa imong example.
like this one?
Yes, sir.
The excess here. You just provide whatever is necessary that would indicate you have a correct solution. Because later on, when you will have a quiz, solution is counted as assignment. Because that will only guarantee me that you actually did it yourself. That you just not sorted to using calculator or any other stuff. Okay? So solution is really separated. There is a separate submission for solution whenever you do your quiz. And that solution is considered as assignment. Okay? So if you say, for example, you wanted to skip this part, this one, then let it be. Actually, I just showed this one from here. It's because this is a purpose for discussion only. But later on, well, I can skip any part. But of course, the purpose here that why I showed this one because I have it from this point. This is actually my given. With this, these are my given, and this is the question. Now that's why the answer is this one. I have to show the process from the given. What is the meaning of the given? And then what will happen now if it is applied in a particular question? This is the result. Anyway, just provide um, pertinent solution in any question. So without further ado, I think we're good with rule number one, unless if you have question. Any other question? Actually, there is also another way of showing this one. Okay, let me just write it here on top. Instead of doing it individually, you can just simply, example, you have the summation of x sub I plus y sub I. Example, that is the given. If this is the given, we understood earlier that the meaning of this is the summation of x sub I plus the summation of y sub I. Actually, we can, the meaning of this one later on, from here, we can have it also this way. Uh, x, or that is x sub 1 plus y sub 1, which is plus x sub 2 plus y sub 2, and then that until whatever is the last. Which is actually, when you have it in this way, or you have it in this way separately, you will still arrive with the same value if this is your notation, or at least your given. So whichever is possible. Okay? So the summation of x sub I plus the summation of y sub I, you can also write it in this way. It's the summation of the sum of x sub 1 plus y sub 1, and then x sub 2 plus y sub 2, plus x sub 3 plus y sub 3, until plus the sum plus x sub n plus y sub n. Okay? By the way, this is rule number one, which is also extended up until you have x sub I minus y sub I. Meaning to say, this rule is similar with this one. The meaning of this is simply the summation of x or the summation of x sub I minus the summation of y sub I. So it's true for, I mean, the case or the situation is true for addition and subtraction. You just have to change the operation involved. Whatever is the operation available or is actually asked. Any question?
Sir, pwede mag-ask, sir?
That's why I'm asking you. Any question?
Okay, sir. Sir, ay mo, kung ko, sir ba, pwede imo to example, katabi lang sa quiz na mo, sir.
Which quiz?
Katabi mong gisend sa pag,
Did I give
Wednesday.
already quiz for this one?
Ha?
Sir,
Did I
lain na
already-
sa kulat na mo, sir.
Wala, imo mingi quiz ana, sir. Then, karon pa na nato discuss. Nya, murag, basin murag lahi ang among pag-compute, sir ba? O, paggamit sa formula.
So you have already a quiz like this?
Yes, sir. Five questions, sir.
Yes, sir. Naa, sir.
Yes,
Moto
sir.
nag-ask
But-
ko nimo ganina, sir, if okay ra ba nga ang solution is direct ra siya, sir, kay ang katong nag-solution mi, sir, kay ay kanang nag-solution ko ato, sir, kay ako ra siyang gidiretso og kanang solve, sir.
Now this is the problem. Because I know I made or I posted a video discussion of this one, but I don't know if you watched the video.
Sir, I watched the video, sir. Wala ni siya, sir. Good. Taman rata sa katong levels bitaw, sir, of variables kato. Wala man tutok man good, sir, kay kuwang og time.
Let me check what happened. I'm starting to be confused already as to what's really your. This quiz was last Thursday, last Wednesday.
Wednesday, sir. Yes, sir.
Mhm. And then the items in the quiz, there were
Wait.
questions like
20 items, sir niya. 5 items ang inuna og question, sir.
let me see. I cannot view the questions also. Wait, I know where to look or to find for it already. Ah, I know already. Okay, anyway, maybe I misposted some items. I should have given you quiz only that is maybe because the topic wasn't finished last time. I'll just remove the 5 items solving for the last quiz and then I'll post another quiz for this Wednesday which already which will focus already on summation notation. Perhaps I can just do that. And then whatever is the total here, I'll just how many points per question for the solving? Is it 5 points? I think it's already two.
I think, sir, kay 3 points.
3 points, sir.
Okay. So at least from 41 minus 15, that will be the total points for last time. And then I'll just give a separate quiz which will be on Thursday about summation notation for you. maybe I overlooked this one because my psychology class, they're quite advanced with you because they have 5 unit subject for this. And then I posted the same question which I wasn't able to cover it with you. Anyway, I'll just do some adjustment later.
Okay ra, sir. Thank you.
Hmm. That's why you will be surprised every time we will have a class. I always ask, where did we end? Where did we stop? It's because it's like I have the same subjects. I mean, relate similar subject sa statistics, but for psychology they have it 5 units, and in your end you only have it 3 units. So technically, I'll have more hours, number of hours discussions. I mean, classes with them than yours. But more or less, the discussion with them is more um, fast forward than yours. It's because of the number of hours difference. So that's why I have to ask you every time we will meet as to where did we end. So at least I will be refreshed. Where should I start? Otherwise, I might give something that is not supposedly for you. Mhm. What happened to this? Mhm. Question bank. Yeah, I remember already what quiz I gave to my. Ah, there. I gave you 5 items. I see. Anyway, so like I said, I'll just give you a separate quiz on this. And then the number of items for the last quiz, I'll just remove the computation part in the total later when I'll do the computation. And then expect that your quiz on Wednesday is all about summation notation and its computations. Okay? So, Mabano, I don't think so. I'll have to answer that question if you're asking me what's the answer for the last quiz, because you might again face the same items. At least you already know how to answer them by this time because we already discussed it. Okay, we're done with rule number one. Let's have now rule number two. Okay, for rule number two, the equation. All right. Right. Okay, rule number three is you have it in this form. The summation of C. Okay, C here, by the way, is a collective term. No, it's an arbitrary or it's a general notation signifying a constant term. Constant term meaning to say a term which values do not change at any point. From the word itself, constant. So if you have it in this form, the meaning of this one, this is by the way, rule number two, is n times c. If you notice here, we left out already the subscript. Because remember last time when we have the summation of all x's in the summation notation, we place there x sub I because it's expected that the variable x there may have different values. It may be 2, 3, 4, any number. But in this case, we left out already the values or the subscript for c because it's not necessary at all. After all, when it's a constant term, it's all the same. It's because it's constant. Okay? So for example, our constant term, the summation of if 5, c here is 5. For example, 5. The number 5. Now you just have to, because it's the summation of all the 5, you just have to find out how many 5s were there. Okay? Instead of writing it, the summation of c sub I from 1I raised up to 5. Now, we can left out this one, actually, some other details of the summation, because when it is C, it means constant. I mean to say, it's all 5 all throughout. You just have to find out how many 5s were there. Okay? In this case, there are 5. So if you have our example, this one, you have the summation of C. Okay? And then this case, C equals 5. Okay, meaning to say the value of C is 5. And then you just have to find out how many 5s were there. Like, for example, your n is 7. So the meaning of this one, under this expression, you have the summation of C equals 5 plus 5 plus 5 plus 5 plus 5. 2, 4, 6, 2, 4 plus 5 plus 5. Meaning to say there are 7 5, which is 35 was added. Now, to cut it short, when you have it in this way, you just have it, the summation of C, that's N, then C. In this case, you only have 7, which is your N, the number of, as to how many entries were there, and since all the entries are just the same, then times 5, which basically you still get 35, which is the same. Okay? Question? Well, I think there's no question. So that is rule number 2. Any question? Now let's move to rule number 3. Rule number 3 actually is very much, it's just like the extension or the continuation for rule number 2. Number 2. By the way, rule number 3 is like this. When you have the summation of C times X sub I. Take note, there's constant term. At the same time, there is an arbitrary variable X. So in this case, when you have it this one, literally, once translated, this is equivalent to C x times X sub 1, X sub 1 plus C X sub 2 plus C X sub 3. That is literal translation. But there's a better way of introducing this one. Whenever you have the summation of C X sub I, instead of doing it this way, this is just equivalent to we isolate, we factor the C. C here is constant. We factor out the C, meaning to say we bring it outside the summation notation, and then we do all the summation and the summation of X sub I. Then later on, we put back X. So it's like it's a separate term now. So we will have now C times the summation of X sub I. Do you get the point? Meaning to say, you have to get the summation of all the x's, and then whatever is left, applying the concept of number 2, we will multiply how many or what is your C. Okay? For example, if you have problem, you have C equals 5, and then you have uh, x sub 1 equals 2, x sub 2 equals 3, x sub 4, 3 rather is 4, x sub 5, 3, 4 equals 5, x sub 5 equals 6, for example. If that's the given, and then our given is like this, or at least the question is the summation, find the summation of C x sub I. Applying the rule, the meaning of this rule, by the way, is simply C, then summation of x sub I. So you have now, our C is 5 times the sum of all the i's. You have 2 plus 3 plus 4 plus 5 plus 6. You add it all together, of course. You have to add whatever's inside following PEMDAS rule. That's 10, that's 20, that's 5 times 20 equals 100. Meaning to say, the summation of x sub I, the summation of C times x sub I can be found as easy as doing it in this form, which in our example will just give you 100. That is rule number 2. Number 3 rather. Well, just to convince you why this is so, now let's look at this. Okay, I'll just remove our example here. And then I just wanted to show you why from this, like I told you, this is the literal translation when you have it in this way, or when this is the given. So, how to show this one into this form? Now, let's look at this. Remember, you have C sub x, A sub, C sub 1 plus C x sub 2 plus C x sub 3. Now, take note, in this notation, applying the laws of polynomials, okay, special product rules, you notice in these 3 terms, C is common. Thus, I can factor out C, meaning to say I can remove it inside the, I can do factorization for this. So removing the C here, if that means to say I'll have to divide all the 3 terms with C so that I can bring this one out. So what's left outside as I factored out C, since this term, the first term have C, the second term have C also, and then the last term have also C, I can remove that one. I can factor it, bring it out. So what's left now? So I factor out C. I have now what's left for the first term as I factored out C is x sub 1. And then what's left for the second term as I factored out C, that is x sub 2. Plus what's left for the third term as I factored out C is x sub 3. See? Which is just very similar with what I explained to you whenever we have this notation or whenever we have it in this form. Remember, this notation here is just equivalent to the summation of all x's and then times C, which is exactly this one. I hope I made it clear to you and you were convinced now why whenever we have it in this form, this is its equivalent. Applying the rule number 3 for summation rules. Questions?
Sir, ang
Okay, go.
kanana sa ubos, sir, ba is, ay kanana sa ikaduha bitaw, sir. O kana, sir, is kanang shortcut lang na siya sa ubos.
This one?
Or kanang, or mo ni ang way sa para makuha ang nasa ikaduha.
When you have given like this, you just have to deal it like this because the meaning of this one is just similar with this. That's why it's called equal. So when you have it in this way, it's just the same when you have it like this. So better do it this way. Because if you have it in this form, literally, this is its meaning. Meaning to say, you have to multiply the constant term and then the first x value. And then multiply the plus the product also of the constant term and the second value. Instead of doing it like that, it's a lot complicated. And I mean, it will be much easier whenever you will just simply do it this way, which is you isolate the C first and then you get the sum of all the x's, x sub 1 plus x sub 2 plus x sub 3, dot, close. You add all the x's first and then whatever is your sum, you multiply to C. You will still get the same answer with this one. When you do it this way or you do it this way, you still have the same answer. Okay?
Okay, sir. Thank.
Okay. So I think we can move now to the next rule. For the next rule, where is the next rule? The next rule is that's rule number 4. Rule number 4. For rule number 4, okay, when you have the summation of x sub I and then y sub I, you notice when you have it in this form, the meaning of this one is multiplication, right? So the product of two unknown variable. Unlike addition, remember last time, if we recall, you have the summation of x sub I plus y sub I is equal to the summation of x sub I plus the summation of y sub I. Remember? That is for addition and the same also for subtraction. But that's not applicable for multiplication. So whenever you have it in this form, it's not equal. Okay, take note my symbol, not equal. This notation is not the same with the summation of x sub I and then times, sorry, this notation, they are not the same. Okay, take note. This one and this one are not the same. Do you get me? But I think there is something that I missed it after. So,
Pero sir, kay summation magyapon siya sir, ang pikas ug pikas. Pero kaning naa sa first nimo sir nga ang summation kay sa gawas, di ba? Ika kaning diri sa not equal niya kay gisama gyapon ang x ug ang y.
yeah, actually, but that's not the same. Whenever you have it in this form and this one, they're not the same. For a while. Where are you? Where are you? Rule number 4. Okay, it's there. Okay, now let's just show you at least an example. Let's say I have x sub 1, or the value of x is 1, 5, 8, 9. X sub 1 to x sub 4. Y sub 1, the value of y is 3, 2, 7, for example. So y sub 1, y sub 2, y sub 3. I have now these values. Now, to show you that the value of this one, if these are the values of x and y, and the value of this are not the same, just to convince to you that whenever you have it in this form, it's not exactly the same with this. Let's show. For this one, the summation of x sub I, y sub I, the meaning of this is I'll have to multiply all the y and x simultaneously. Uh, what do you call this one? X sub I times y sub I, and then I'll just have to multiply it all together later on. So it's like this. First, the meaning of this is I'll multiply all the y, the x. So x sub 1, x sub 2, x sub 3, x sub 4, y sub 1, y sub 2, y sub 3. So I'm going now to multiply everything. So it's like, for this one, it's like x sub y, so x sub 1 times y sub 1. So that is 1 times 3. And then, wait. I'm not sure, but the terms here, I mean the y and x don't have the same values, or the same number of values. Uh, well, let's just make add one more here. Let's say this is 4 y sub 3. So you have one, if this is our notation, so you have now like this. X sub 1 times y sub 1, then you have the value of x sub 2, which is 5, times the value of y sub 2, which is 2, plus 8 times 7, plus 9 times 3. And then this is 4 plus 10 plus, wait, 8 times 7, 56 plus 27. So that's
4,
going to be
4 na, sir.
which
Sir, how
4?
come na
X
4 ang
Y
una,
sub
sir?
4, sir. Y
Wait.
sub 4 is 4.
This is 4.
36.
This is 36. So that is now 36, 62, 72, 75 is the answer. Okay, when you have it in this form, I hope my multiplication and addition is correct. No? That's 3, 10, 56. This is 36. Sorry. 75 plus 30, that's 105. Is it correct? 10, 80, 92, 95, 105. 105. Okay. So from here, let us also show it in this way. What must be the value of, these are our given, and this is our notation. The summation of x sub I, and then you have times the summation of y sub I. It's like this. Whenever you have it in this way, the meaning of this, you have to add all the x's and you have to add all the y's, and then you multiply afterwards. So it's like this. 1 plus 5 plus 8 plus 9. Then times 3 plus 2 plus 7 plus 4, which is 10, 18, 23, plus 10, 20, 16. Sorry, times 16. So 23 times 16, that is 18, carry 1, 12, 13, 3, 2, 8, 6, 3. 300 is my multiplication correct? 368. 18, carry 1, 12, 13, 3, 2, 8, 6, 3. So 368. You see the difference? They don't have also the same value. Clearly, it shows that whenever you have this form, it's not equal to this. How is that even possible? Because, remember, in multiplication, it's like this. Where is that? I think there is no. I mean, that's just the result. So clearly, when you have it in this form, it's not equal to this. So what's the meaning now if you have it in this way? So simple. You just have to start to respectively get the product for each. X sub 1 times y sub 1, and then plus x sub 2 times y sub 2. Where are you? As consequently also, as a result, we understand that the summation of x sub I squared is not also equal to the summation of the quantity x sub I then square. Do you get me? All the more, these two here are not also the same. Because in this case, the meaning of this, okay, let me erase this. The meaning of x squared, x sub I squared, the meaning of this is every value of x will be squared first before you get the sum. So example, if this is the x's I have, x sub 1 is 5, 1, 5, 8, 9. The meaning of this, if this is the given, that is going to be like this. Uh, 1 squared plus 5 squared plus 8 squared plus 9 squared, which is 1, 25, 64, 81, which is 65 plus 25, that is 70 plus 20, 90, 90 plus 81, that is 171. Is my multiplication correct?
Sakto, sir.
Okay, that's the value. Now, if you have it in this form, summation of the quantity x sub I then squared. I sorry, where is the okay? The summation is outside. The meaning of this one, you have to get first all the sums. So that means say 1 plus 5 plus 8 plus 9. Then whatever is the sum, you squared it. So you have 10, 18, 23. That's 23 square, which is 23 times 23, 9, 6, 6, 4, 9, 12, carry 1, that's 5. It's 529. Okay. 129. See, they are not the same. It's because clearly these two do not have also the same value. Clarification? Hello? Hello? No question. Very good. So I'm gonna cut this one. You can ask question before I'll dismiss the class, or else assume that everything is clear to you. Unless if you have question. Hello? Any question? You can open your microphone and camera now.
Sir, my question, sir.
Ah, yes.
About kay sa x sub I, sir, is kung ano siya, automatic na siya, sir, kung wala siya kung identification na 1 or 2 or 3, automatic i-copy na to tanan mga x's.
No, the meaning x sub I, let's take this. Remember, when you have x sub n, that is a particular value of x, which is general notation that would signify anything that is the last in that sequence. So that refers to the last value in that sequence. But when you say x sub I, that refers to a particular value in the sequence, which it could be 1, 2, 3, 4, 5, whatever value I you're referring to. It's like this. The difference between x sub I and x sub n, x sub n normally signifies that that's the last x in the series or in the sequence. While x sub I, it would refer to any value in the series. That includes x sub n. Am I making sense? I mean, can you repeat your question? I don't know if I answered your question.
Ay, nani, sir, akong question is, ang x sub I, naman siya x sub I, sir, sa wala, then iyang given access is x sub 1 to x sub 5. So, kung ang given, ang given ko to equation is x sub I, i-copy ra to tanan, sir. From x sub 1 to x sub 5.
No, the difference apart because if the question in the example you're given is x equals 9, and then you have 5 values. It's understood that the 5 values there, the first one is x sub 1, x sub 2, until x sub 5. There are 5 x's referring to. Okay, do you get that? And then if the given is the summation of all x sub I were x, or where I starts from 2 until 4, so that only includes x value number 2 until x value number 4, excluding the 5 and then the first one, because in your notation, it's only from second until the fourth. That's why you notice there's the notation. You have I equals the summation of x sub I, where I starts from 1, starts from 2 until 4 only. So you only add the value of x sub 2, x sub 3, and until x sub 4, excluding x sub 5 and 1. Because in the given, it says only from x sub 2 until 4 only. So the fifth x entry is no longer included.
Okay, sir.
Okay?
Gets.
Any other clarification? I hope so that it really makes sense to all of you. So with me saying that one, I hope things are clear to us. Expect that on Wednesday, you'll have a quiz about summation notation for the entire Wednesday. Okay? And then, do not be surprised if I'm not gonna list any points, the 15 points from your first quiz. I'll just settle that one whenever I'll compute the prelim grade. I'll just deduct that one because what I'm going to do, whatever is your score from the LMS, I'm going to bring that to my E-class record. And then from the E-class record, instead of having there the total of 41, for example, I'll reduce it already by 15. So that will be the total points for quiz 1. Do you get me? So don't be surprised if you cannot find any deduction of 15 points in the LMS for quiz 1. I'll just do that one in the computation of the prelim grade already. And just to make sure that I'll not forget that, by the time I'm going to compute the prelim grade, kindly remind me, okay? Otherwise, I might not reduce the 15, I might not remove the 15 points, which I am supposed to. I hope that's clear. Okay?
Okay, sir. Thank you, sir.
Just remind me, of course, so that I will not forget. Any question? You can open your camera now. Like I said, we're done. We're done here. And I hope I wasn't too fast today. Am I?
Yes, sir. Mas okay ka ron, sir.
Really, Mabano?
Yes, sir. Nakasabot good ko.
So the basis now here is you will be being able to understand.
Di man, sir. Mas makasabot mo, sir. Basta, kanami na mabasa, makita sa namang pag-solve ni mo, sir ba?
Of course, that's fine. There's no solving.
Magsulat pa man ka, sir. So, tanaw, ginamo kung masabta na mo ba? Kaya mo take time pa man yung pagsulat. So, masabot-sabot pa na mo.
Of course, last meeting's discussion, there's no solving also. So what am I gonna write on the board if there's nothing that I'll be showing you with?
Mga gani, sir. Yes,
Or
sir.
maybe, Mabano, you just get to use with me because you were with me already last time. Somehow you were able to adapt and adjust already.
Okay, sir. Bye, sir. Thank you, sir. Klase kami, sir.
Go ahead, you can leave now.
Okay, thank you, thank you.
Bye-bye, sir. Thank you.
Yes,
Okay, sir.
sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye.
Thank you, sir.